Good morning, students. We're going to see with coefficient of restitution. So what is meant by coefficient of restitution is it is defined as a ratio of velocity of separation, that is relative velocity after collision, to the velocity of approach before collision. Okay, so before collision divided by after collision, this is separation and this is approach. Okay, so that ratio, if you see, that is said to be the coefficient of restitution. Clear? So it is defined as a ratio of velocity of separation after collision to the velocity of approach before collision. Clear? So when you write this as equation, we get E is equal to velocity of separation after collision by velocity of approach before collision. Separation, it is written as, since it is after collision, v2 minus v1. This is before collision, so it is u1 minus u2. Okay, so this gives the equation for E. Okay, this is coefficient of restitution. Now in elastic collision, the velocity of separation is equal to the approach. So we can write as u1 minus u2, which is equal to v2 minus v1. So when you divide this, we can consider that value to be equal to 1. Okay, so we can say that coefficient of restitution is equal to 1 where in the elastic collision. Clear with this? Now E is equal to 1. If suppose E is equal to 1, then there is no loss of the kinetic energy. Okay, so it has a same kinetic energy, that is also called as a perfect elastic. Clear? When the value of E is equal to 1, then that body is said to have the perfectly elastic body. This gives the value of E, it should be greater than 0 and less than 1. This is the problem we are going to see. Show that the velocities of equal inelastic bodies are v1 by v2 is equal to 1 minus e divided by 1 plus e. Okay, taking with the formula velocity of separation divided by velocity of approach. And so this is the formula which we know already from the elastic collision itself, is it not? v2 minus u1, v2 minus v1 divided by u1 minus u2. This is also from velocity of approach. Okay, substituting the u2 to be equal to 0, so we get v2 minus v1 divided by u1. Okay, now this is the value of e. E is equal to this, is it not? So bring this u1 this side, so we get v2 minus v1 is equal to e into u1. Okay, so have this equation as it is. From law of conservation of linear momentum, okay, we can write this as m1 u1 is equal to m1 v1 plus m2 v2. Yes, now this m gets cancelled, so we get u1 is equal to v1 plus v2. So this value of u1, when you substitute in this equation, so we get this as v2 minus v1 is equal to e into v1 plus v2. Okay, now just multiply this term inside. Okay, so we get this as e into v1 plus e into v2. Okay, so this side we have the term as it is, which is v2 minus v1. Okay, now bring this v2 to this side, and this v1 we are going to bring it to other side. Okay, so we get, already we have the v2 term here, this v2 we are going to bring it to this side, so it is minus e into v2, which is equal to, this side we are already have with ev1, so ev1 plus, because this is already minus, so plus v1. Okay, what is the common term here? v2. So when you take this outside, so we get 1 minus e. Okay, and same way here also the common term is v1 and the remaining is e plus 1. Okay, now bring this v2 down, and this term you are going to bring it down here. Okay, so v1 as it is divided by v2, which is equal to, because this you are going to bring it down. Same way here, when you bring this 1 minus e divided by, this is already e plus 1, so e plus 1 can also be written as what? 1 plus e. So we got the equation as v1 by v2 is equal to 1 minus e divided by 1 plus e. So we have proved with this. Clear? Thank you.